Thanks for joining us for Watershed Watch in Kentucky's presentation on a simplified approach to understanding and rating your stream's ability to provide habitat that helps support aquatic life. If your habitat rates well, but you don't find much living in your stream, there's a pretty good chance that the water quality conditions may be harming the in-stream organisms. Or if you've found good water quality indicators from your sampling, but you now find that the habitat values are poor, it may be time to work on a habitat restoration project. For many years, Watershed Watch has had a habitat assessment protocol, but some samplers have indicated that the process was too tedious or time-consuming, so it hasn't been utilized as much as we would hope. This simplified approach, based on protocols from Maryland's Department of Natural Resources, was developed to encourage broader use. If more people use it more frequently, we will have better data to evaluate conditions throughout the state. It also ensures that more people gain an important general understanding of what conditions are optimal for habitat and the underlying complexity of stream systems that serve as a critical component in a healthy overall ecosystem. In order to conduct this assessment, you will either use a paper form that can be printed from our website or use a web app version. You will enter the same basic information at the top of the form, or this may be pre-populated for you in the app. Then you will check off one or more of the land uses through a visual observation of the surrounding area, your familiarity with the area, or even a Google Maps search if you are feeling ambitious. The next portion of the form provides space for you to enter any odor or visual observations of water color or materials or substances floating on the water surface. Guidance for making these observations is provided in the online habitat materials as well as in this presentation. The next page of the form lists 9 stream corridor characteristics for you to rate from good to poor. Observations for these ratings will include the stream itself as well as the land on either side of the stream. After completing each of these observations and ratings, you will total your score and compare it to a habitat scoring chart to determine your stream's overall habitat rating. Here's the rating analysis showing your scores that are considered poor, marginal, fair, or good. The associated descriptions provide a little more information about what you may have observed and what improvements may need to be made to raise the overall stream rating. Before we delve into each of the 9 stream corridor characteristics, we need to be sure everyone understands that habitat simply refers to the natural home or environment of an animal, plant, or other organism. Ideally, we'll find lots of different types of habitat that support many different life forms in a stream and its surroundings. A greater abundance and diversity of life implies a stronger, more resilient overall ecosystem. Again, we'll be considering features both within the stream itself and around the stream. The area adjacent to a stream or river is called the riparian area or riparian buffer. Your assessment form includes notation of land uses in the area. This is important because land uses can contribute unique pollutants, either directly or indirectly, as stormwater runs off of the land and picks up contaminants from the land used for those purposes. This slide shows the land use categories listed on your assessment form, each with unique impacts to water. For example, urbanized areas may contribute petroleum products from vehicles that may leak fluids in parking lots and on roadways. Or fertilizers applied to lawns may create runoff of nutrients such as nitrogen and phosphorus to nearby waterways. Land used for pasture in agricultural areas may contribute bacteria and pathogens from livestock manure, as well as nutrients contained in the manure. Cropland may erode and contribute soil and sediment and runoff traveling over land and into the nearest water body. Thus, land use is an important factor in assessing water quality and what measures may need to be taken to improve it. The next section of your form provides the opportunity to note smells you may detect at the stream site. Your nose is a good tool for information about possible pollution problems. Here's a listing of some of the odors you may detect and common causes. A rotten egg smell may be a sign of raw sewage or decomposing organic matter. If you do find evidence of raw sewage entering the stream, you should report that concern to your city or county engineer for further inspection. A chlorine odor may be coming from an upstream sewage plant discharge, as chlorine is often added to treated sewage before sending it to the receiving water body. It may also be a sign of a swimming pool being emptied or overflowing, or an industrial discharge. Sharp, pungent odors may be indicative of chemicals or pesticides in the area or in the water itself. These can be coming from crop or lawn applications or from other sources. A musty odor often accompanies raw or undertreated sewage or manure. Depending on the area, these may be more likely to come from a human or livestock source. Rancid, sour odors may be easily identifiable as dead animals or dumpsters. A gasoline or petroleum smell may be coming from industrial uses in the area or illegal dumping of waste, and commercial wastewater or wash water, such as from a car wash, may have a sweet, fruity odor. You can also look for visual signs of pollution. The color of the water may give you clues to many different pollutants and potential pollutant sources. A brown color, along with floating particles, may indicate that soil or sediment is entering the water, possibly through stream bank erosion and possibly from land runoff sources, such as construction sites or cropland. Colors ranging from green to yellow to blue can signify algae, sewage, fertilizer runoff, or even cleaning supplies for vehicles. White colors can come from paint, grease, or concrete, as well as swimming pool backwash. Lighter gray colors, along with a musty odor, can indicate gray water from sinks and washing machines or other wastewaters. Darker gray colors may be caused by raw sewage or other decomposing waste materials. Check for the rotten egg odor in combination with this color sighting. Various colors, including red, black, blue, or purple, can be coming from dyes, paints, and inks, probably from manufacturing sources. And an orangish-brown color is likely related to iron in the soil or surrounding bedrock. This color may also be coming from land that has been mined. Visual signs of pollution may also be in the form of floating indicators. The top 3 photos show things you might see that result from natural processes, such as the breakdown of organic matter, like leaves or twigs, or the growth of bacteria that feeds on elements in the surrounding soil or bedrock. The bottom 3 photos are signs of human contributions from household sewer, automobiles, or other oil uses, and from human sewage. Now we'll talk about the 9 different stream habitat characteristics on the back of the assessment form and how you rate them on the scale from poor, which is worth 1 point, to good, which is worth 4 points. The floodplain refers to the area next to the stream or river where it is likely to overflow during heavy rainfall events. It's likely to have a lot, as in more than 90% of the floodplain area, covered by vegetation, including trees, understory shrubs, or non-woody plants, and restrictions from grazing or mowing in this area. So a good rating includes lots of plants, bushes, and trees, and a fair rating is given when there are at least some. We care about floodplain vegetation because it provides habitat for amphibians and terrestrial wildlife. It also absorbs floodwaters, which lessens impacts to the stream and our communities. The floodplain vegetation is ranked as marginal when most of the trees and shrubs are gone and mowing or grazing has limited plant growth. And we'll rank this characteristic as poor when very little plant life is present. Channel alteration refers to evidence that the stream has been moved or changed by people. Some evidence of this can include non-natural ways of stabilizing stream banks, such as the placement of large rocks, concrete, or metal mesh baskets of rocks called gabion baskets. You may also see long stretches of straightened stream that were adjusted to create more farmland or allow other development. Dams and bridges may be blocking flow and causing straightening, or dredging or removal of gravel and sand from the stream may be obvious. We care about this because straightened channels allow for faster water flow, which causes more erosion and damages stream habitat. A good rating for this characteristic is given to streams that have the freedom to bend and curve across the landscape and are not constricted by man-made structures. A fair rating is assigned to streams that have some straightened sections, but also have some natural bends. You can see that these examples for marginal and poor conditions have very straightened stream channels, with the example for poor also flowing along a paved channel. Embeddedness is a technical term for the amount of soil and sediment surrounding the rocks on the bottom of the stream. If a stream bed shows a lot of embeddedness, the rocks are almost completely surrounded, as is shown on the graphic on the right. We prefer to see a mix of gravel, cobble, and boulder particles that are minimally surrounded by soil and silt. This creates more surface area for macroinvertebrate and fish shelter, spawning, and feeding. The layering of fist-sized and larger rocks also creates a diversity of niche spaces for aquatic organisms to live and reproduce. In this photo showing a good level for embeddedness, you can clearly see the rocks covering almost all of the stream bed, with very little silt or sand covering them. As the rocks on the stream bottom become more covered with sand and silt, our ratings decrease. In the photo, you can see that rocks are about half covered with silt, giving that stream a marginal rating for embeddedness. If the rocks were completely buried in sediment, the stream would be considered poor for this habitat consideration. Characteristic number 4 assesses erosion of the stream bank. Erosion along a stream can add dirt and sediment to the stream, which harms aquatic habitat. Erosion can also lessen the availability of habitat cover along the stream banks. Ideally, we will see stream banks that are just above the water level of the stream. This ensures that aquatic creatures have access to stream bank habitat and plenty of water. Once the stream banks become higher than the water level due to erosion, access to habitat decreases. In the photo on the left, noted as good, the stream banks are only slightly above the water level of the stream in comparison to the photo on the right, where the banks are notably higher than the water level. These two examples show increasing levels of stream bank erosion. You can see that it would be very difficult for fish or aquatic macroinvertebrates to find habitat along these stream banks. The marginal conditions on the left show much of the exposed stream banks significantly above the water level, and the banks on the right are very high and removed from the stream itself. When assessing macroinvertebrate habitat, we also look for available cover on the bottom of the stream. This can include submerged logs or tree limbs, leaf litter packs, and smaller or various sized rocks that appear to have been in place for a while and unlikely to move. We want to see a variety of habitat niche types at the bottom of the pools, which will include a mixture of gravel and sand substrate materials and lots of aquatic plants and associated root mats. When the stream substrate is all mud and clay, or even all bedrock, scoring for this category is poor. These two examples show streams with few rocks, wood, or leaf litter available for habitat. Fish like to seek various habitats for feeding and spawning, including slower, deeper pools of water and undercut stream bank areas where the roots provide shelter for spawning or laying their eggs. The photo on this slide shows a stream bank with plenty of undercut bank areas that have tree roots extending over the water. The tree branches will also help keep these areas shaded and cool. The fewer pools, fallen tree limbs, and overhanging banks, the poorer the fish habitat rating. The stream's vegetation buffer, or riparian zone, refers to the amount of plants, shrubs, or trees on the land along and adjacent to a stream or river. The width and density of plant cover in this area tells us about its effectiveness at providing ideal aquatic habitat, as well as absorbing and removing excess stormwater and associated pollutants. Ideally, the buffer width will be greater than 50 feet on each side of the stream and provide a variety of vegetation types, including grasses, shrubs, and trees with little to no mowing or other human impacts. The shorter the width of the buffer, the less favorable the stream habitat. The photo above gets a good rating. Notice the wide bands of large trees mixed with other plants on both sides of the stream. And you can see that the overhanging tree limbs provide a lot of shade to help keep the stream cool. Stream bank stability is directly related to the previous erosion category, in that the increased erosion of the banks impacts the steepness and height of the bank slope. When large areas of bare dirt, exposed tree roots, undercut areas, and trees falling into the stream are seen along the stream banks, it's a sign that the banks aren't stable. Based on the rating descriptions, how would you rate this stream bank? It should receive a poor rating. There's a lot of exposed bare dirt on a very steep stream bank, and you can see how the bank is caving in and falling into the stream. So it's not very stable at all. As with most of these habitat characteristics, we're looking for variety, this time in relation to water depth and its velocity, or how fast it's flowing. This variety supports a wider range of organisms. Stream experts have special names for depth and flow types in the stream. A pool is probably just what you would imagine, an area of deep, slow-flowing water. A riffle occurs where the stream course drops and the water flows quickly over rocks, producing rough, bubbly water. A run is the fast-flowing water between the deeper pools and the shallower riffles. These riffle-run pool sequences will help slow the water and release its energy. This lessens its power to erode the stream banks, which, as we have seen, can cause other habitat problems. The fewer of these different depth and velocity combinations you see, the less ideal the habitat. For instance, a good rating is given to streams that have all four areas: fast deep water, fast shallow water, slow shallow water, and slow deep water. For reference, water is considered deep for smaller headwater streams when it's above the knee. For larger streams with bigger drainage areas, it's considered deep when it's waist high. And water is considered fast flowing when you can see that the surface water is broken with turbulence. If you see only 3 of these combinations, the rating here is considered fair, 2 considered marginal, and only 1 combination considered poor. It's worth noting that in western Kentucky, where the land surface is typically flatter with less change in stream gradient, it's natural to see fewer flow types, and you're especially less likely to see those associated with faster waters such as riffles and runs. After performing this habitat assessment, you're likely to have some recommendations for ways to improve the habitat. For instance, if the buffer areas are sparse, maybe you need to organize a tree and shrub planting. If you find lots of sediment and soil on your stream bed, Maybe you need to ensure that erosion control measures are being used on upstream construction sites and raise awareness about this problem. If the banks are very steep and high above the water level, upstream flow volumes from excessive stormwater runoff may be causing too much bank erosion. Perhaps there are stormwater control measures that could be used to help some of the runoff filter into the ground and help slow in-stream velocities. There are many insights that can come from performing a habitat assessment of your chosen stream site. If you have any questions along the way or after you have your findings, please feel free to contact your Watershed Watch's Basin board members for help.